Okay, so here we are looking at the output of the Verizon mean ratio code that we ran. So here we're looking at the bootstrap distribution for the ratio of these two means. And we drew these two vertical lines in our histogram. And so just to remind you, the blue one is the original sample. And the red one is the mean of all bootstrap statistics. And so one thing that we see here is that they're not the same. They're off a little bit. But what we first wanted to do was calculate the 95% confidence interval to estimate this. And so that means we were trying to find like the middle 95%. So let's check out the statistics that we get from that. And so a 95% bootstrap here, we can see is going somewhere from about 0.328 to 0.837. So what we could say to interpret that is there's a 95% chance the interval between 0.328 and 0.837 that contains the actual ratio of the mean ILEC repair time to the mean CLEC repair time of all repairs that Verizon makes. And so the observed one that we got, so this is the blue line, is this one over here, and the red line is this value over here. And so they're off from each other just a little bit. And the reason why is we have this tail to the right on the distribution of the bootstrap statistics. And so the QQ plot that we generate, that is over here, we can see that it is not as normal looking as the bootstrap distributions for, say, the difference in two means. And that's again because we have this tail that we have on the right. So what this tail is doing is it's pulling the mean in red, it's pulling the center of the bootstrap distribution up a little bit to the right. But there's our confidence interval, and this gives us some sense of what the difference in these two times are. And so what would be totally fair would be if the ratio of these two means was equal to 1. That would mean they take exactly the same amount of time to do the repairs regardless of who the customer is. And what we can see here is that this ratio is definitely less than 1. So what that tells us is that they're making repairs for their customers more quickly than they are for their other competitor customers. So the denominator is larger than the numerator, but that's a pretty big spread in values. One last thing I just want to mention here is we can construct confidence intervals. Why bootstrapping is so nice is even if we don't have a central limit theorem to compare the ratio of two means, which we don't, so we don't have a theoretical formula for describing the sampling distribution, then bootstrapping is pretty much all we can do, and we still can get a pretty good picture from the bootstrapping, but we see that we do need to be mindful that there is a little bit of bias from that tail on the right.